Hi everyone there. Hope everyone are doing great. Myself Archana M of Sri Venkateshwara College of Engineering pursuing my graduation in 6th of EC domain. Today let us discuss about solar space cooling of building under the topic non-conventional energy sources. So what is solar space cooling of building? A solar space system collects solar power and uses it in a thermally driven cooling process which is in turn used to decrease and control the temperature for purpose like generating chilled water or conditioning air for building. There are many different cooling cycle techniques using various different principles to function. There are three of the most popular techniques which are being used in the present scenario and they are included as they are absorption cycle, Descant cycle, solar mechanical cycle. Let's look after the block diagram of solar space cooling of building. So the block diagram is given in the picture. Here the sun rays which has been emitted by the sun which is been collected by the solar collector, and the solar collector is been connected to the heat exchanger as well as the circulation pump. So when the heat exchanger is been connected to the one of the absorption chiller, so it will produces and which will be recycled back to the circulation pump. Here at the first part or the off part of the solar space cooling of building, it is been producing the hot water. So it is named as hot water circuit respectively, and the second part is nothing but the chilled water circuit. Here the absorption chiller is being connected with two terminals. One is for cooling tower and another is for chilled cooling panels. So as we see in the picture, the respective chillers has been connected to the respective points or respective parts. So at the second part of the solar space cooling of building, the chilled water is being produced and which is named as chilled water circuit. Therefore, by using this block diagram or by just producing or by just knowing this block diagram, we can make it that hot water circuit and chilled water circuit will produce hot water and chilled water respectively with the help of absorption chiller. So the absorption chiller is nothing but which is a main part or a main block which is being used for producing the hot and cold water or chilled water. So now let's see how the solar cooling works. Regardless of the technique being used, a solar cooling system typically includes three core components. They are a solar collector, such as a solar panel, which is used to convert solar radiation into heat or mechanical work. A refrigeration or a air conditioning plant that is used to produce the cooling. And the final one is a heat sink that collects any rejected heat or radiates it away from the system. While techniques used to achieve solar cooling vary, the end goal remains the same. Utilize an external heat source like a solar panel to collect ambient temperature and then use that heat with a refrigerant to create pressure within a closed loop of refrigerant, thus enabling the solar cooling system to work. A refrigerant is a substance or a mixture that absorbs heat from the environment and can create refrigeration or heat conditioning if it is combined with the other necessary components like compensator or evaporators. In most cooling cycle, the refrigerant will transition from the liquid phase to the gas phase and then back again to achieve its cooling purpose. So as we studied, there are main three popular techniques for cooling cycle and they are absorption cycle, descent cycle and solar mechanical cycle. The first and the foremost is the absorption cycle. In an absorption cycle, the cooling process progresses as follows. The first point is the absorber holds an absorbent refrigerant mixture that is delivered to the generator through a liquid pump. The generator makes the absorbent refrigerant mixture and heats up using the external solar energy that has been collected through a source such as solar panel. The solution starts to boil in a reaction to the heat, turning water into vapor which flows into the condenser. The condenser liquefies the water vapor, rejecting heat in the process which is collected by the heat sink. Here, the heat sink which is being used to collect the remaining heat or rejected heat and which will protect the system by the other radiation. The new liquid condensate is then directed towards the evaporator through an expansion valve. Finally, evaporation of the refrigerant at low pressure causes the evaporator to absorb the heat from the cooled space, creating the cooling effect. At the end, the vaporized refrigerant turns to the absorber and the cycle repeats. Solar power is responsible for the driving this cycle. So here the main basic or the source which is used for the absorption cycle is the solar power, which will be emitted by the sun, or where the solar rays can be collected by the solar collector, and then this process can be achieved without any disturbance. The next one is the desiccant cooling system. It operates with both liquid and solid desiccants. The desiccant cooling process progresses as follows. Desiccant absorb the water vapor and remove the moisture from the process air in the dehumidification or absorber unit. A transfer results from the difference in vapor pressure, thus releasing heat due to the condensation of water and creating a heat exchange. In the air is then introduced, the air is then introduced into the space or into an evaporative cooler for further cooling while the diluted desiccant is sent to the regenerator. However, before the diluted desiccant can enter to the regenerator, it must pass through a liquid-liquid heat exchanger and a heating coil in order to raise its temperature. Once in the regenerator, the heated, diluted desiccant is exposed to regenerative air, causing moisture to transfer from the diluted solution to the air. This transfer is due to the created difference in vapor pressure. Next, the resulting more concentrated desiccant passes through the liquid-liquid heat exchanger once again as well as cooling coil and then moves back into the dehumidification unit, allowing the cycle to repeat. So now let's look after the application of solar cooling. Solar cooling is primarily intended for two main purposes. One is for refrigerating food storage and space cooling, or it is also called as air conditioning. Solar cooling can be seen in vehicles like RVs or campers, which uses the system of refrigeration. Vapor absorption refrigeration systems, which are used in industries where extremely low process temperature are required, as well as large thermal capabilities, also display the use of solar cooling. Perhaps the most beneficial application of solar cooling is its ability to provide cooling system to countries that otherwise would not be able to handle the total electrical and energy cost and burden required for conventional cooling system. Solar cooling greatly reduces the amount of energy required to refrigerate necessities such as vaccines and agricultural products, which in turn creates cost savings and benefits the environment by using renewable energies and reducing the use of ozone depleting materials. Thank you.